let me remind you, you don't have to write any of this down yet. Let's remind you, what the heck, if I were to say as x approaches infinity, first of all, what's that asking about? X approaches infinity, it's asking about where are the horizontal asymptotes. And if my function happened to be 5x squared plus 2x minus 7 over 5x squared plus 3x minus 4, what would be that horizontal asymptote?
0. Or wait.
1. What dictates my horizontal asymptotes?
X squared.
5x squared over 5x squared. 5x squared in this case over 5x squared. What's going to cancel out? Like everything, right? 5 over 5 is going to get me. Answer is 1. If you showed this much work, didn't even circle these. If this was the work that you showed, totally fine on that topic, right? But what if I said, what is the limit as x approaches infinity? Again, you guys can just be little sponges here, absorbing and spitting out the answer. What if I said that? 5x to the second over 5x to the 12th. Yeah, who remembers? What's the rule? If it's greater on the bottom, the horizontal asymptote is always going to be 0. Here's why. It's still the biggest exponent on the top and the bottom are dictating what's going to happen. You agree 5 over 5 cancels, and I'm left with x to the second over x to the 12th would be 1 over x to the 10th, if I cancel those out. And if you ever plug in infinity to the denominator, 1 divided infinitely many times, that's going to get me 0. Some people, me as a kid, would have to go through this to remember that the answer was 0. Other people, Danny Main's like, exponent on the bottom is bigger, boom, the answer is 0 every time. And that works too. Okay, lastly, what happens if that exponent on the top is going to be bigger? Yeah, infinity or doesn't exist. So let's say that it was x to the 12th up there. So again, 5x to the 12th over 5x squared would just get me x to the 10th, right? And what happens if I take infinity to the 10th power? Sadie said infinity or does not exist. And what that means is this graph is looking something like this potentially, and that it doesn't have a horizontal asymptote. Okay? That's what we did on Friday. Let's go finish that. So we're on page 28 of your notes. I said, let f be this function, a lot going on in this function. Which of the following is a horizontal asymptote of f? They're just asking, what's the limit as x approaches infinity? And Mr. Ooh, you did not fall for my trick. Danny Main, what did you say the answer was? -7. How the heck do you get that? X4.
Yeah. 7 is the whatever thing that multiplies the x.
Coefficient, love it.
Yeah.
But it's not 7 because you chose -7 and not 7.
Well, I circled negative.
Yeah, totes. So just a reminder, I just love that you saw that was a -7x to the 4th with the biggest exponent and its coefficient on the top and a +1x to the 4th on the bottom. Those would simplify to just a -7. Danny, so good. This guy down here, again, we're looking as x goes to infinity. We've seen this topic before. As x goes to infinity, we've seen this before. How might I be able to break this apart? Say it.
Could you do 5x over x plus sine x over x?
Yes. And here's where we might get a little confused about the rule. And Sadie, you said, yeah, could we break it apart this way? You're absolutely right. Because then, Sadie, what's 5x over x going to do?
5.
That's just going to get me 5. And then you guys, what's the limit as x approaches infinity of that graph?
0.
Yeah, as x approaches infinity, we're going to 0. Final answer? What would have changed if this was as x approaches 0? It would have been 6, Liv says, because this still would have been 5, plus this limit would have been 1. Final answer 6. Liv, future engineer, just saying. Okay, this part we're going to get a little uncomfortable because Rolly's answer is going to look different than Brown's, and it's okay. Because I'm just giving you some things that we need to outline. Does yours have this stupid, I hate it when my formatting does not work out, you guys. That's so annoying. I needed a tab here. Okay, we need to focus on this and try to draw a graph that represents all of this. I say we start with some infinities, meaning when something equals infinity, If my limit is going to infinity, where's it going? As x approaches infinity or negative infinity, if x approaches a number and the function is going to infinity, wouldn't it be going up? And if my function is going to negative infinity, be going down? What do we have in both of these situations? A vertical asymptote, exactly. So both of these, we're gonna have vertical asymptotes. At what number? 4. So I'm gonna go to when x is 4, and I'm gonna draw a vertical asymptote. And it says, as I approach 4 from the left, we need to go to infinity. Matney, as I approach 4 from the left, I'm going to come in from the left side. I'm going to just draw a little bit, just saying, I don't know what it's going to connect to, but I'm going to approach infinity. But Matney, I only say your name because if you were like this, Matney, and you drew it further down, that's fine too. It doesn't matter. We just need to come in from the left of 4, and we're going up to infinity. But yours might be in a different spot, and that's okay. It's just as long as you're going up. And I've taken care of this requirement. As x approaches 4 from the positive side, I need to go to negative infinity. 4 from the positive side, I need to go to negative infinity. So I'm going to just draw a little part of this graph because I don't know what it's might going to need to connect to. And I'm going to be like, all right, well, it's got to go down. And I'll connect something to it in a bit. But for right now, I've got those two things taken care of. You down with that, Danny Main? Ooh, Danny, you got something else drawn on there. What else? You got a little point. Where'd you put your point? He says, well, I got a point, -3,1. That's like... There's only one option there. Boom. That's a point. I love that. Nothing to the imagination there. The next thing I would look at, you guys, is as x goes to infinities. If my x is going to infinity, which direction is that going? To the right. Exactly. A horizontal asymptote. Exactly. As x goes to the right, my y's have to level off at 5. Here's what I'd say. As x goes to the right, my y's have to level off at 5. Here's 5. I need to have a horizontal asymptote at 5, and that's because that right there. If my x's are approaching infinity, that's referring to an asymptote. Now, JC, if your x is going to infinity and you're saying your function is going to 5, Jack, you could be like this. You could come up from the top, or Thomas might have been like, oh, I came from the bottom and did that. Either way, they're approaching 5, so it doesn't matter. But maybe they're going to have to connect down here. Who knows? But I'm just saying, as x approaches infinity, we got to go to 5. Either one of those will work. So I've taken care of this one. And as x goes to negative infinity, we also have to go to 5. Again, it doesn't matter. You could come from the top or you could come from the bottom. It doesn't make a difference. We're going to connect things anyway. Guys, we have 2 more requirements. That's it. Oh, no, gosh, these up here. I didn't even see these up here. Do we want to look at -1 or oh, gosh, so many things. Let's start with -3. How about that? As x approaches -3. Here's -3. We got that point that Danny Main pointed out. As we approach -3, is it from both sides? From both sides. We got to equal -2. As I approach -3 from both sides, my function, my limit has to be -2. So I'm going to go like this. Whoops. I'm going to go like this, and I'm going to go like this. Let's say Thomas did this instead. Thomas, maybe yours is like that. It doesn't matter, because as I come and approach -3 from both sides, do my fingers come together? Oh, that's -1. Oh, Lord. We have to put a hole there. We have to because of that dot above it. Hold on. There we go. I need to put a hole there. Guys, this could look anything. It could be like this. It could be any kind of function as long as your fingers come together at -2. Mine looks a little shoddy. I'm just going to go like this. I'm going to act like a little parabola. Why not? Okay. So I took care of that one. Okay. How about this one? As x approaches -1, only from the right. -1, only from the right. We got to equal 4. So as I approach -1 from the right, I got to equal 4. Okay. I might draw. I'm just going to be like, all right, I'm coming in there. We could close it up. We could leave it open, doesn't matter. Here's another one with -1. -1 from the left, they want to be -4. -1 from the left, they want it to be -4. Look what I already have here. So I could either connect it and then go to -1. And then I would have to go open circle.
How do we know which one to open circle and which one to close?
Good call. It doesn't matter.
Okay.
One of them needs to be open, one needs to be closed. Or if you're like, this looks a little crazy, I'm just going to go ahead and connect that with the straight line. You're welcome to do that too. Again, everyone's is going to look different. Man, my iPad is glitching. Okay. I'm going to go ahead and connect those there. Yeah, one needs to be open, one needs to be closed. And we took care of that. Only one last requirement, or are we done? This one here. As x approaches 1, my y has to go to 3. As x approaches 1, my y has to go to 3. Mine conveniently is kind of right there. And it's going to be from both sides. So I'm going to say from the left of 1 and from the right of 1. You could make this closed or open. It makes no difference, you guys. I just left it open. Who cares? And they said, sketch a function that satisfies these conditions. So we've now satisfied them. I'm going to go ahead and connect everything else that is just kind of floating. So this guy, I'm just going to connect here. This one, I'm just going to connect down here. And we're good. Is the precision of these important? No. Thomas, can I point out if you're as x1 to infinity up over here, sorry, this is taking. If your horizontal asymptote up here came from the top, you could always go like this, bloop, and you can always cross through a horizontal asymptote. You could always cross through a horizontal. Guys, we will never cross through a vertical asymptote. Never, ever. Horizontal, all good. Last topic, in my opinion, is going to be the easiest topic. It is a lot of words, but here's how simple it is, Mr. Main. Ready? If the temp was 62 degrees this morning, and then it's going to be 85 degrees by 2 p.m., did it have to be 80 degrees at some point in that time interval? Rolly's like, yeah, that's it? Yeah. So we've got this whole theorem. And it seems a bit redundant, right? So this is called the intermediate value theorem. Whoa, I just crossed it out as opposed to highlight it. Yes, because of the intermediate value theorem. You guys, because temperature is a continuous function, right? To go from 62 to 85, could I just jump over 80 and not be 80 at some point? No, that's not how temperature works, right? So to go from 62 to 85, do we have to cross through every single number from 62 to 85? Yeah. So we're going to say due to the intermediate value theorem, I'd say let's just write it maybe this first time, just so it gets in your pencil, in your brain, intermediate value theorem. To me, this one is a very common sensey. If you just want to write IVT, AP is totally good with that. IVT is totally good with that. Okay, so now let's go ahead. Oh, yeah. If I was clocked by a police officer going 90 miles per hour on my way to Penn State, did I have to be going 30 miles per hour at some point?
Yes.
Right? I can't be getting to 90 by, even if I got stick shift, right? Even if I go, you still have to pass through, even just for a millisecond. So, yes, I did have to be going 30 due to, or you could just say by the intermediate value theorem, IVT. Did I have to be going 92 miles an hour at some point? Wilsey, you said no? Why?
You never even want that.
Right, but could I have?
Yes.
I could have gone 92 and then backed off it a little bit. I could have, but it's not within that interval, right? This is the intermediate value theorem. Are we going to have to write things a little bit more mathy than just a yes or no? Yes, and here's how it's going to be. I said a function that is continuous, continuous on a closed interval. Okay, so here's how I would like to describe this. If I were you, I'm a big believer of a picture. And I would say if it is continuous on a closed interval from some A to some B, they said. This is my picture. I went like this. Boop. Since it's a closed interval, do I keep my endpoints closed or open circles? Got to close them up, right? It's got to be bounded. We are including the endpoints. It says a function that is continuous on that closed interval, they use brackets, that's why you close my circles, takes on every value between f of a and f of b. Do you agree if this is a, this y value would be f of a? If this x is b, this y value would be f of b. Draw a picture and explain this in your own words using a numerical answer. Here's what I would say. Let's go ahead. What do you want this y value to be down here, you guys? -5. You guys matched. Love it. What do you want this y value to be up here? 8. I dig it. Thanks for making them something different. Okay, so here's how we're going to say this. It says draw a picture and explain this in your own words. So what we would say is, okay, if there's a function whose y values at its endpoints are -9 and 7. Let me just say this out loud and then we'll kind of write it down. Then my y must also equal every single number in between. Do you agree the values of this function, the y values of this function, have to be every single number between -5 and +8 if it's continuous? Now, could my function have been like this? And they could have been numbers bigger than 8. Or they could have been numbers smaller than -5, but we have to meet every single number in between. So we're going to say, if, this is a lot of words, I apologize. There is a function whose y values at its endpoints are -9 and 7. Then there must be, then y, oh golly, not -9 and 7, -5 and 8. Matney, you get to pick your own starburst this time. -5 and 8. Then the y must also equal every number in between due to the IVT. So these y values have to be -4. Did my y value have to be -3 at some point? Does my y have to be 0 at some point? Some point. Could my y have been 9 at some point? Yeah, does it have to be? No. Has to be everything between -5 and 8. Okay, so now let's go be a little bit more mathy. Here's this h function. We do get a calculator. Okay. Can the intermediate value theorem be applied to guarantee a value from 1 to 5 where the value of the function is 0? So you guys, it's saying, does my function have to equal 0 at some point? You with me, Thomas? You with me, Jack? We're like, I don't know. Let's go see what my function was at one endpoint. Let's go see what h of 1 was. I don't think we need a calculator for that. What would 1 cubed minus 2, what are we at there? -1 plus 4, 3 minus 5? What do we get?
Wait, why would we plus and 4?
Oh golly, if x was 1, 1 minus 2 is -1, right?
You said add 4.
Oh golly, minus 4, we're at -5? Minus 5 again? Sadie. Candy. What about on the other endpoint? What would h of 5 be? Holy smokes. So if we got 5 cubed, oh golly, 5 cubed minus 2 times 5 squared minus 4 times 5. Let me know if I'm typing in anything wrong. And we got 50. Okay, look at what it says. Here's the function. Here are my values on the endpoints. Does my function have to equal 0 at some point? Liv, you went like this.
I thought it was positive.
Oh, I got you. But so what are you saying? Say it again. Yeah, she's like, okay, to go from -10 to 50, you guys, is 0 in between there? Yeah, so here's what I would write if I were you. From -10 is less than or equal to 0, which is less than or equal to 50. So I'm just plugging in my endpoints. That's the smallest. That's the biggest. 0 has to be in between. So I would say, yes, by the IVT. And this is the perfect rationale, you guys. Plugging that in right there. Showing this number is in between the value from my endpoints. Kate.
What are the one?
So let me show you what this tells us. 1 and 5 are x values. So this is saying when x is 1, my y value is negative 10. And when x is 2, 3, 4, 5, my y value is 50. My graph could be as simple as this, but I had to cross through 0. Or my graph could have been like this. Did I still have to cross through 0? Yep. Or my graph could have been like this. Woo, 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 woo. But I still had to cross through 0. But Kate asked a great question. These right here, it says, is there a guaranteed value on the interval 1 to 5? These are both x's, both of them. From x of 1 to x of 5. So it's talking about that interval there. Okay, you guys, now we just have a table. Now we have a table, selected values of a continuous function. So even though I only gave you 6 points, the function is continuous. So even though we don't know what's going on between 2 and 1 here on these y values, it is continuous, okay? Where the fewest number of zeros, this is just a 0 is just when the y is 0. That's all a 0 means. From this interval, look at this interval, Kate, 20 to 30, these are both referring to x's. These are x's. Here's x of 20, here's x of 30. So it's talking this entire time, what is the fewest number of zeros that we could have? When would my y have to equal 0 if this was continuous? Would we have to pass through 0 to go from 2 to 1? No. Could I have? To go from 2 to 1, I could have dipped down, but I didn't have to, right? Because we didn't change signs. How about from 1 to negative 3? Do you have to cross through 0? We had to go at some point. I don't know if it's at 22.1 or 23.9, but at some point we'd have to cross through 0. How about from a negative to a negative? Nope. Negative to a negative? Negative to a positive? Yup. So what's the smallest number? 2. And look what it said, 2, because the function changes signs between 22 and 24 and 28 and 30. The function changes signs. Negative to positive, positive to negative, you got to go through 0. Good job, you guys. Okay, this one we do grab a calculator, so let's go snag one. We got a calculator. Tank is leaking water. The amount of water left in the tank is modeled by this continuous function, W. W is measured in gallons, T is measured in minutes between 0 and 60 minutes. Can the intermediate value theorem be applied and guarantee that there's time in the first hour that the tank contains 100 gallons? In the first hour, what are the points that we want to double check? W of blank and W of blank. T is minutes, very good. We want to check 0 and we want to check 60. First of all, intermediate value theorem only applies when the function is continuous. So we're feeling good about that. It is continuous. We plug in a 0 here. A 0 in for t. What are y'all getting? Did you guys get 487.805? AP requires 3 decimals, you guys. Pass the decimal. Tens, hundredths, thousands. We have to go to the thousandth for every single answer. Sound good? How about W of 60? I'm just going to go edit my answer instead of negative. Oh, shoot. Instead of 0, I'm going to put a 60 in. I got 45. Anyone else get 45? 0.103. So it says, can the intermediate value theorem be applied? Yes, it can, because my function was continuous. And does it guarantee that there is a time in the first hour that the tank had 100 gallons?
Yes.
Is 100 between 45 and 487? Yeah. So we're going to say, because W of t is continuous, you can say CONT on 0 to 60. They like specifics on this interval from 0 to 60. And 45.103 is less than or equal to 100, which is less than 487.805. Exactly. Yeah. Yep. I should have thrown in that what I was trying to answer before this. I would say, yes, IVT guarantees, guarantees the tank contains 100 gallons because W of T is continuous and 100 is between those two values. This is a perfect answer. We had to state that the function was continuous, so IVT applies. We used the words IVT. We used our intervals and our closed function. We're good. Yeah, good call. So this last one says, let F be this function, and Danny's saying, what is going on? This is e to the negative x over 4. The intermediate value theorem applied on this closed interval guarantees a solution to which equation? Here's my interval. You guys, you're going to want to go check what is f of 24 versus what is f of 28. We want to see which one of these 4 answers is going to be included in my interval. Anyone get f of 24? Give me 3 decimals, 10.806. F of 28. It's plugging 28 in here. Anyone get one for that? Yep, 66.140 you said? Perfect. Which one of these lies in between this interval? C. So the AP test will have 6 free response questions that will each have 3 or 4 parts. This one happens to have 3. So let's take a peek. This is from AP Classroom. The number of fish in a pond at time t years is modeled by this. And where f is a continuous function. Ooh, it's continuous, so what applies? IVT applies, okay. And f of 0 is 80. So at 0 years, what do we have? 80 fish in the pond, right? At 0 years, we had 80 fish. That's a fun fact there, okay. Find the limit as t goes to infinity. As t goes into infinity, this is asking for that horizontal asymptote, right? Of n of t. You guys, if t goes to infinity, do you think we want to look at the top, middle, or bottom function if t is going to infinity? The bottom. Infinity is bigger than 8, right? So I'm going to look at this bottom one. So I'm going to say, all right, the limit as t approaches infinity of 200 plus 80t over 2 plus 0.05t. This is our horizontal asymptote rules. What's the biggest exponent in the top? What's the biggest exponent in the bottom? Yeah, we just have an 80t on top and 0.50t on the bottom, right? 80 divided by 0.05, my t's are going to cancel. Danny Maines, you come up with that? 1600. And it says, explain the meaning of that in the context of this problem. What do you think? So yeah, in terms of like years, ponds, fish. We're not going to have more than 1,600 fish in this pond. I love that you said capacity. I love that. And as time just goes on forever, right? So as time, I would just say as time goes on forever, the number of fish in the pond will approach 1,600. Or if you have any kind of version of that, like Ione might say the pond only has a capacity of 1,600 fish. Great. Perfect. Danny was saying like, oh, there'd be a horizontal asymptote at of 1,600, and we just want to make it a little bit more real worldy than that. Love it. Okay, so this is kind of how they're integrating, do we remember those horizontal asymptote rules into a real world? Is the function n continuous at 8? This is, we talked about continuity. For something to be continuous, not only does the limit have to exist at that point, but the point has to be the same value of the limit. So maybe we just remind ourselves, for something to be continuous, the limit as x approaches c has to equal the value of the function at that point. So I'm saying for something to be continuous, the limit as x approaches c of the function has to equal the point when x is c. You would not need this general statement for this problem, but this is kind of helping you decide what you want to write. So you guys, we got to figure out the limit as x approaches 8, right? And you agree if I'm trying to approach 8, if I'm trying to find the limit, I got to do it from both sides. I got to do it from both sides. So I would start with the limit as, in this case, it's actually t approaches 8. Which, from the left, which function should I look at? Middle or bottom? Approaches 8 from the left. Left less than, that's how I think of that. I'm going to do 25t plus 150. And we want to go see, is that equal to the limit as t approaches 8 from the right? From the right, those would be values greater than 8. So I'd say 200 plus 80t over 2 plus 0.05t. This didn't say calculator active, but you guys, we're going to use a calculator, okay? Let's go plug in that 8 here, and that 8 here, and let's go see if those equal. Anyone get a value on this left side? 350? What about on the right side? We also got 350? You guys, does my limit exist? Yeah. What about f of 8? Or in this case, it's actually n of 8. Is n of 8 also 350? Which one of these would I plug in 8 to? Top, middle, or bottom if if my t is 8? The bottom, right? Didn't we already do that? Didn't we plug it into the bottom right there? And what'd you get? 350. So are we going to say this is continuous or not? Yes. So we're going to say continuous at t equals 8 because, and we're going to just say the limit as t approached 8 of, I should have said n of t, equals n of 8. That is my perfect notation. This is some funky new writing, you guys. This is hard. This is new notation, new justifications. I'm saying it's continuous at that point because the limit equal the value of the function. You guys are killing it. You guys are killing it. Last one. Justify the function n is continuous. Ooh, they said n is continuous at 6. Is there a time between 0 and 6 that n of t had to equal 250? What theorem are they wanting you to use? IVT. Thanks, birthday boy. We got to go do IVT. What are my endpoints that I'm going to check? 0 and 6, girl. We want to know what is n of 0, what is n of 6. N of 0. We plugging that in the top, middle, or bottom? N of 0, and you're like, whoop. That would just be f of 0. Did they tell us what f of 0 is? Yeah, they're making us dig, you guys. That'd be f of 0, which is 80. And maybe you want to just draw yourself a little like, oh, snap, they did give us that info. What about n of 6, top, middle, or bottom? Middle. 25 times 6, 150 plus 150? Is that 300? What do we think, you guys? Does the n of t have to equal 250? Yeah. And so we're going to say because n of t is continuous, the IVT, intermediate value theorem, applies because I would say 80 is less than or equal to 250 is less than or equal to 300.